All right, now is a fun part. In 4.4 here, we're going to do some curve sketching. So we're going to put together a whole lot of things that you've done in the past, including the more recent relative extrema and inflection points, but even some from earlier, and use them to put together a nice sketch of a function f of x, the graph of a function f of x. So the idea here is we're not looking for exactness here, a sketch that incorporates a lot of the important features of a function's graph. So let's take a look at what we would really consider as some of these important features. Okay, so if we're given f of x or y equals f of x, then one of the first things we should probably consider is the domain. Right? That tells us important things like where there might be places where the function's undefined, how far are we going towards plus infinity or minus infinity. So always a good thing to note. And then of the features, intercepts are a nice thing to consider. X-intercepts, remember to get those, you set y equals f of x equals 0, and then you find x. And you could have one or more or none or no x-intercepts. Y-intercepts, you set x equal to 0 and find y. Okay, so those intercepts will give you nice locations on the axes where we have some points. So we don't have to have any of them. We could have some of them. So you just see what you get. All right, asymptotes. All right, so that was looking for vertical and horizontal asymptotes. If you remember the vertical asymptotes, these were when we got limits of infinity. And here, we're looking for things like zeros in the denominator, etc. So all the things that we look for when we look for vertical asymptotes. Horizontal asymptotes, on the other hand, were limits at infinity. Okay, so we have to take, the limit as x approaches plus and minus infinity of f of x in order to figure out if there are any horizontal asymptotes and where they are if there are some. All right, the next thing was that we went into were extrema, max and mins. Now, here we're mostly considering relative extrema, but if we did some further analysis, we could decide whether they were absolute or not. But as far as finding the relative extrema, you remember that's an analysis of the first derivative. So that would start with calculating the first derivative, finding critical numbers where the first derivative is 0 or undefined where the function is defined, and finding intervals of increase and decrease, putting that on a number line chart, and then determining relative max and mins. Okay. So that gives us some nice features of where the graph is topping out and bottoming out. And then we looked at inflection points. Okay, so inflection points came off of the second derivative, and these had to do with concavity. So for here, we would be finding the second derivative. We then find our concavity, figure out where it's concave up, concave down, and that will lead us to determine whether we have any inflection points and where they are. So all of these things are important in putting together a nice sketch, and you're going to be amazed of how nice a sketch of a function that we can do purely on this information. And realize it's nice because it's going back, if you think about how this is developing, basically in the intercepts, that's a concept from pre-calculus, talking about what points on a graph are important. Then we have asymptotes, which was an early calculus idea dealing with limits. And then we have two more recent ideas based on derivative. It's extrema, the first derivative, and inflection points, the second derivative. So it's a nice development of all these ideas. And again, the goal is to find important information about a function. We're going to use the graph to represent it. So the goal is not really just let's end up with a graph of a function. It's to learn all the information that's going into the graph.